Okay, in this question we're given a polynomial. We don't know this k thing, but in part A1 we're given that x plus 2 is a factor, and we've got to show that k is 10. So we need to use the factor theorem, which is in chapter 2 notes, but the idea is there's a particular value that we can substitute into p and we get a particular answer for it to be a factor. And you must write down especially what this answer is you're expecting, and then logically go through and solve for k. Okay, if you don't say what p of that particular value has to be to begin with, you may not get the full marks of the part of the question. Once you know that x plus 2 is a factor, well, I mean, this is a re-entry point, even if you couldn't do a1. a dot e2, you just need to set up the grid method, so you've got x plus 2 as the factor you know. You fill in the rest of the grid, so it multiplies out to this expression. You know what k is now. And that will give you x plus 2 times a quadratic factor, and you factorise that quadratic in the normal way to end up with 3 brackets, 3 factors. And that's where you stop. Some people like to claim that x is certain values, but you can't at the moment. You don't know anything about p of x equaling 0, so you can't solve this. But what you can do is leave 3 brackets, and that's the answer you should give. Then we need to use the remainder theorem. So we've had factor theorem, now we've got remainder theorem. We need to find the remainder when dividing by this factor, this bracket. So once again, there's a value of x coming from that you can substitute in. Put it into p of x, make it clear that you know you found the remainder when you get that answer, but the answer will just be a number. Examples of that again in chapter 2. And then part C, all of these are re-entry points. You know what k is from the first part of A. In part C, we've got to sketch the curve with this equation. So you should know the general shape of this, indicating the values where the curve crosses the x-axis. Now we do want this to equal, well, on the x-axis, y equals 0. So when this equals 0, you can use your factorisation. If you didn't end up with a factorisation here, you can make one up so that you can use this as a re-entry point, and you have 3 values of x where it crosses the x-axis, and then for the y-axis, the y-intercept is when x is 0. So substitute x in, get the y-intercept, and it's a standard shape of a cubic graph. There's only one shape for a cubic that will fit the points you've got.